Okay, I hope you guys are doing well. This video is for section 7.1, 7.2, solving systems. There's a note, this is in your notes. There's a note at the top about the special cases. If you get no solution, it means they don't intersect. And if you get infinite solutions, it means they're basically the same line, they're equivalent. An example of no solution might be you get 7 equals 0, which obviously is not true, which is why that's no solution. An example of infinite solutions might be 8 equals 8, which is true, so they are equivalent. So first we're going to review substitution. So looking at example 1, substitution, we want to take one of those equations and solve it for one variable. Doesn't matter which equation, doesn't matter which variable. So I'm just going to take the first equation and solve it for x. So I'm going to minus the y to the other side. Hopefully you see what I did there. Then I'm going to take that and I'm going to substitute it in for x in the other equation. So instead of an x, I'm going to write 4 minus y. Always use parentheses when you're substituting, just in case there's a negative that's going to make a difference. Then I combine like terms, 4 minus 2y, solve for the one variable. Divide. Y equals 1. Once you have one variable, you need to plug it back into either of the two equations up above and find your other one. I'm actually going to use the top equation because I prefer plus. Y plus 1 equals 4. Sorry, x plus 1 equals 4. And then subtract to solve for x. And then finally, don't forget you always write your solution as a point. We just found the point of intersection. So I write my answer as a point, 3, 1. Okay, moving on to number 2. Obviously, it's getting a little more complicated. We're not in integrated. When did you learn this? Integrated 1, integrated 3 anymore? Okay, so still substitution. So I don't want to just choose any variable this time. This time I want to look at the more complicated equation, which is... Sorry, I got cut off. This time I want to look at the more complicated equation, which is clearly the top equation, and when I plug something in, I want to plug it into the easiest variable there. So y does not have a lot happening to it, right? It's not being squared, so that's the easiest variable in that equation, which means that's the variable I want to solve for in the second equation. So go ahead and take the second equation and solve for y, get y alone. So hopefully if you moved everything and you dealt with that negative y, you got 2x plus 1 for y. Then we're going to plug that in using parentheses to the y in the other equation. So x squared plus 4x minus, this is where the parentheses are super important, equals 7. Distribute the negative. Combine like terms. And then you should notice that this is a quadratic. You can't add the 1 and try to factor out the x or anything crazy like that. The only way to solve a quadratic is to make it equal 0 first. So make it equal 0. Once it equals 0, you have choices. Factoring, zero product property, quadratic formula, or completing the square if you love completing the square. This one is factorable. Pause your video and see if you can factor and finish solving for x. Factoring x plus 4, x minus 2. Zero product property, x equals negative 4, x equals 2. Please know all we found was x. It is not negative 4, 2. That is not how this works. We found 2 x's because if you think about it, the original graph was a parabola and a line. So chances are it's going to hit 2 times. So right now we have the 2 x values. Now we need to take each x value and plug it into either equation to get y. Might as well plug it into the simpler equation. So 2 times x minus y equals negative 1. And then 2 times this x. If you don't know what I'm doing, I'm grabbing this equation and I'm plugging them in. 2 times that x minus y equals negative 1. Take a minute and find each y value that goes with each x value. Your answer is going to be 2 points. If I plugged in -4, it's going to be -4 comma whatever I get. If I plugged in 2, it's going to be 2 comma whatever I get. Pause your video and see if you get what I get. Okay, if you're super careful dealing with that -y, you should get the point -4, -7, and the 0.25 are our solutions to that system. Okay, moving on to elimination. In elimination, we have a goal. Let's write this down. We want the same coefficient opposite sign. For one of the variables. So for example, we could have 7x plus ... over -7x plus ... This would be a goal. Or we could have 2x minus 5y ... and 3x plus 5y ... That could be a goal also. It doesn't matter which variable, but they need to be the same number, opposite sign. So to do that, we want to multiply our equations by something. So when I look at the equations 5x and 2x, those both go into 10x, so I can make those be positive 10x and negative 10x. Or 3y and 4y, those both go into 12, so I can make those be 12. The reason I'm going to choose the y's is because, look, one of them's already positive and one of them's already negative. So I won't need to do any extra work to try to get that opposite sign. I'll just have to make them be the same coefficient. So 3 and 4 go into 12, so I need to multiply this one by 4, and I'll write that here. You multiply the whole equation, right? Whatever you do to the left, you have to do to the right. So times 4. Then if I want same coefficient, opposite signs, I need to multiply the second equation by 3. Everything gets multiplied by 3. Now we can see we've accomplished our goal, positive 12y, negative 12y. Elimination is sometimes called the addition method because now we add these two equations together, 26x. These ones cross out, that's why it was our goal. Add the other two together, and now you have one variable. Divide to get the answer to that one variable. And now we know x. Don't forget, the solution to a system is not just a single variable. It's the point where they cross. So now I need to plug that number into one of the other two equations and find y. Pick an equation, it doesn't matter which one. Plug x equals 3 in and see if you can find your y value. Pause your video. Okay, hopefully you got the point 3 comma negative 2. Those two lines would cross at the point 3, negative 2. Okay, take a minute and read example 4 to yourselves. First thing I see is that we're dealing with two different types of solution. The two different types of solutions make up our variable. The 10% solution can be x. The 30% solution can be y. Also, it tells us that we need a total of 10 liters when we're done. So the amount of 10% solution is x. The amount of 30% solution is y. So x plus y has to equal 10. So liters of the first solution plus liters of the second solution has to equal 10 liters total. Then we start dealing with the percentage part. So x is my 10% solution. So 10%, 0.1 times however many liters of that solution I have, plus the y represents the 30%, so 30%, 0.3 times however many liters of y I have. They want that to equal 15%, so 0.15 times there's 10 liters of that in the end. So this is what our original system of equations look like. First thing I would do, let me just write an example on the side. If this problem was like x over 2 plus, 2x over 7 equals 3. When we see fractions and we don't want to deal with fractions, we often multiply by the common denominator, which would be 14. If I multiplied that by 14 here and here and here. The 14 and the 2 would cross out, and I'd have 7x plus. And the 14 and the 7 would cross out, and I'd have 4x, etc. It's the same idea with decimals. I don't want to deal with all these decimals. So I want to multiply everything by 10. So that means move the decimal once, right? So move the decimal once, and I get 1x. I don't usually write the 1, but I will in this case. Move the decimal once, and I get 3y. Move the decimal once and you get 1.5, but then times 10 equals 15. So I probably should have shown this step first. 0.15 times 10 is 1.5, and then move the decimal once by multiplying by 10 again. That's why it's 15. So bring down my other equation. Now it's a normal system of equations. Maybe you didn't understand quite how I wrote the equation to begin with, or what I just did with multiplying by 10 to get rid of decimals. But start here. Let's use elimination, just because that's what I'm going to use. My opinion, but you can do it either way, looks like the x's would be the easiest to cancel out. So do what you need to do to make the x's cancel out, and then see if you can solve for y. So use elimination. The x's are going to cross out, so you should be able to find y, and then we'll stop and compare. Pause your video and find y. Okay, so hopefully if you found y, divide by 2, you ended up with 5 halves, or 2.5 liters. So we need 2.5 liters of y represented 30% solution. Remember, it had to equal 10 total, so just a little quick subtraction. You could have plugged it in and found it. X would have ended up equaling 7.5. So 7.5 liters of the 10%, because X represented the 10% solution. This is not written as a point. I am solving a word problem, and I answer the word problem over here using words and labels, liters of 30% solution, etc. So hopefully this was a review of solving systems using substitution and elimination.